All right, so for homework last night, we had to evaluate the 6 trigonometric functions for 11 pi over 6. Okay, so I gave you all the same angle, so you just had to work with the same numbers. All right, I don't want to throw everything out for you there. If you didn't notice, along with the video that I posted yesterday of our lesson, I put up also a copy of the unit circle that I used. Okay, so, oh crap, what did I just do with it? It's gone. There we go. Nope, come on. All right, so there you have the unit circle, all right, the one that we used yesterday in class. If you have your own, you know, it might be a poster on your wall. You love math so much, who knows? You can use that, but you do have this for your reference. All right, so we're looking at 11 pi over 6, so you go around the unit circle. Okay, if you, I mentioned this yesterday, but if you do notice, there is somewhat of a pattern that appears, right? So like I said, here we have, you know, the 30 degrees, it's pi over 6. If we reflect that over on the other side, we have 150 degrees, which is 5 pi over 6. And then over here, we would have, you know, this 30-degree angle here. This is 7 pi over 6, right? So there's kind of like this mirror thing going on in two directions, horizontally and vertically. So eventually you might, you know, use this unit circle enough where you start to memorize. But like I said, I'm not asking you to memorize this. But if you do notice those patterns, it makes things a little easier for you. And even those patterns appear in the x and y values of the unit circle, right? Here you have root 3 over 2, comma 1/2. Over here, you also have root 3 over 2, comma 1/2. It's just that this is negative because of the quadrant we're in, right? Again, here we have the same thing, but they're both negative. Over here, we have the same thing, but the y is negative. Okay, so once you kind of learn that pattern, you don't really need the whole unit circle. You just have to remember this first quadrant, and then you can map it everywhere else. All right, but I'm not going to spend too much more time talking about that. So again, we go to 11 pi over 6, which is also 330 degrees, and we have the coordinates root 3 over 2, comma negative 1/2. All right, so just be careful of your signs. Those are important, and if you don't have them, that messes it up, and you might get the wrong answer. Okay, it'll only be wrong in the fact that it's negative instead of positive for the most part. All right, so I'm going to move this over to the side. Okay, we only need that 11 pi over 6, so I don't need the other half of the graph. I'm just going to look at this. So first, our first two easiest ones are the sine and cosine, because we just have to worry about the x and the y value. Okay, be careful here. I know a lot of people think sine comes first, so it's the x value, all right, but it is the y value, all right? So the sine of pi over 6 is our y value, which is negative 1/2. That's all you got to do. Nothing else too fancy there. The cosine of 11 pi over 6 is the x value, which is the square root of 3 over 2. Now, I don't know if I mentioned this. We are going to leave it with the square roots. Do not calculate it. Do not, you know, I don't want a rounded number. This is as accurate as we're going to get. Now, unfortunately, you know, we might have to deal with things like common denominators. And like we saw yesterday, if I have a radical underneath, we have to change that, okay? But this is a lot better than reading 0.707, you know, whatever that is, and things like that. All right, so tangent, let's remember, is sine over cosine. So we're going to put the sine value, okay, or y over x if we're talking about the coordinates. So we're going to have negative 1/2 over root 3 over 2. So I'm going to keep change flip. So negative 1/2 times 2 over root 3. Okay, so I kept the negative 1/2, changed to multiplication, took the reciprocal there. Those eliminate each other, and I'm left with what I just actually wrote down, 1 over the square root of 3, which is equivalent to the square root of 3 over 3. All right, if you wrote 1 over root 3, okay, you wouldn't be wrong. I might subtract 1 point just because it's not in proper form, okay? Again, in math, we don't like to divide by square roots. With fractions, we like whole numbers in the denominator. Cosecant is the opposite of sine, 1 over y. So that'd be 1 over negative 1/2, which is negative 2. Right? Or you can just flip your sign over. Secant is 1 over x. So here we have 1 over root 3 over 2, which means we're flipping this. So we have 2 over root 3. So again, I taught you the trick yesterday, but I'm going to write out what we technically do. So I'm multiplying top and bottom by the square root of 3. In the denominator, that's going to leave us with 3. And in the numerator, we have 2 root 3. Okay, so the secant of 11 pi over 6 is the square root of, is 2 times the square root of 3 over 3. Again, if you gave me this, I'd give you points for being right, but I might subtract a point or 2 for not being proper. And then cotangent. Now, there's a few ways that you can go about doing this. You can flip your tangent, or we know that it's the inverse, so it's going to be x over y. I'm sorry, not inverse, reciprocal. So you can set it up either way. Both ways will get you the same thing. And I'm going to do the inverse of tangent. So we're going to have 1 over square root of 3 over 3, which gives us 3 over the square root of 3. And if we do the same thing that we did above, and we multiply, okay, I'm going to have 3 square root of 3 over 3. A lot of 3's there. Those eliminate each other, and we're just left with the square root of 3. Oh, I didn't write that. Yeah, there we go. Square root of 3. So I do realize that some of you may not have access to typing in square root. I forgot to mention that yesterday. If you're typing this out, and I didn't give you guys multiple choice, but you can always write SQRT. That means square root, and then put in parentheses whatever is underneath the square root. Right? So you can write square root of 3 like this. Something like this here. Okay, you would write 2 square root 3 divided by 3. Okay, I would understand what that means. All right, any questions about the homework? Those are the 6 trig functions.
Yeah, I have a question.
What's up?
It's about the tangent. I didn't understand how it was square root of 3 over 3. Because when we cancel the 2, we're left with negative 1 over square root of 3.
Okay, so you got to the point. Oh, that should have a negative sign with it. I'm sorry. So you got to the point. You got this?
Yeah.
Okay. So right. So like I said, technically you're correct. Right? If you punch this into the calculator and you punched what I wrote into the calculator, you'd get the same decimal, whatever it may be. 0.6 something. Who knows? Okay. But so I mean that was an option. I didn't tell you to give me in fraction form, so if you gave me a decimal, that would be okay too. But we don't anytime we divide by a square root, it doesn't really make sense in math. We like to divide by whole numbers. We can't really have a fraction where the denominator goes on forever. Okay, the square root of 3 is called an irrational number, which means it's not a fraction. I can't rewrite this as a fraction. So we don't like having that in the denominator. Okay, so there's a few rules with, denominators that are kind of unwritten rules, especially in the higher math. So in order to get rid of a square root, okay, we have to multiply by the square root of whatever that is, right? There's two ways to look at that. If I do the square root of 3 times the square root of 3, that's the square root of 9, which gives me a whole number 3, okay? The other way to look at it is I can rewrite it as the square root of 3 squared, and they eliminate each other. And we're just left with 3. Okay, so that's nice and all. We want the 3 in the denominator. But I can't just multiply the denominator by the square root of 3. That would be changing its value. So I have to multiply the numerator and the denominator by the square root of 3, because technically here, I'm just multiplying by 1. If I multiply something by 1, I'm not changing it. All right, that's, that's just your, I forget what it's called. The identity property of multiplication. That's going way back to algebra. So we multiply by the same thing, right? The square root of 3 times over the square root of 3. So in the denominator, it removes it. I bring the negative along for the ride, which I think I forgot to do before. And in the top, we just combine whatever we have. So 1 times the square root of 3 is just the square root of 3. Actually, real quick, let me show you. So if we have 1 divided by the square root of 3, we get 0.577, right? And this would go on forever. If I do the square root of 3 divided by 3, we still get the same decimal. Okay, so there's the same number. It's just that this looks nicer to a mathematician. Okay, so you wouldn't, like I said, you wouldn't be wrong with this answer. But that is just nicer. Does that kind of answer your question? Okay, you're welcome. You're welcome. Any other questions or issues with evaluating using the unit circle? Okay, so that kind of brings me to a few things that we're going to kind of stem off into. So when we evaluate, we could always evaluate with the calculator, right? It's there for us. Now, we don't have the cosecant, secant, and cotangent, but we have the sine, cosine, and tangent. If you are using a calculator to evaluate, now, these, what do we got? 12, 16 angles, right? So 90, 0, 180, 270, and all these in between. These are known as common degrees or special angles, okay? And we get these from the special triangles that I showed you yesterday, the 45, 45, 90, and the 30, 60, 90. Right, so you do have this reference to evaluate any of your trig functions. But obviously, moving forward and in real life, we're not always going to be taking trig function values of nice angles, right? I might have 212 degrees, right? That's not on here. If you're using the calculator to evaluate, you have to be very careful. Whether it is your phone or a basic calculator, there are always 2 modes for the calculator. Okay, here you hit mode. There is the degrees, if you're punching in degrees, or there is radians. If you are using pi, if you do not see the degree sign, always make sure your calculator is in radian mode. Okay, it will give you very different answers than when it is in degree mode. Okay, so if you are using your phone, I know I have an Android, so it's going to be a little different, but I think they're pretty similar. Okay, so again, if you're holding it normal, I don't know if you guys have this stuff, but you just have your basic calculator. You might see that there, okay, RAD. That changes it. Usually when you're in radian mode, it tells you somewhere. Okay, do I have one of the old calculators?
For iPhone users, if you guys just like turn your phone, there's a thing that says rad all the way at the left, like to the
Right, I
left.
think it would be like down here, right?
Mm-hmm.
For the iPhone, yeah. So you can switch it that way. If for whatever reason you have one of these calculators, okay, it tells you in the lower right corner. There you see DEG. It is in degree mode. Okay, so you would find mode. I forget where it is on this calculator. Oh, a DRG button. You hit that. You go over to radians, and now it is in radian mode. Okay, so if I did, the sine of pi, right, that gets me an answer because I'm in radian mode. If I'm in degree mode and I do the sine of pi, that gets me some crazy decimal. All right, so just be careful moving forward when we do start evaluating with whatever you're using. Now, if you're using something online where you're just typing it in, most of the time the computer program will figure out what you're trying to type in, but always make sure that you are in radian or degree mode. Okay, so we're talking about a few different things. So today and tomorrow we're going to cover some things. First, I want to talk about specifically sine and cosine. Now, these are the words spelled out fully. We only use the abbreviations because it's much simpler writing 3 letters than writing cosine of whatever we have. And then especially when we get to the other ones like cosecant, secant, right? I don't want to write all that out. Give me 3 letters. So for both of these, they do have similar properties. Okay. The domain for both sine and cosine is all real numbers. You can plug anything in, whether it's in degrees or radians. You can find the sine of 10,000 pi over 6 or something. I don't know. Okay. You can plug anything in. There's no restriction on your domain for sine and cosine. When we get to the higher ones, we see some restrictions. The range. Well, if we look at right now, our source for sine and cosine is the unit circle. Okay. The range is always between 1 and -1, right? For both of those, right? No matter which way we're looking at, we'll never get above 1 and we'll never go below -1. Right? And if you plug anything into the calculator, you might get 1, you might get -1, but you'll never get a number larger than that. Okay, it'll always be a decimal. Now the other part, I've mentioned this before, okay, but sine and cosine are special because they are known as periodic functions. So if I'm looking at the graphs, all right, so we did a brief look at the graph earlier this week, and we'll take a look more in depth probably Maybe not until the third marking period, but we'll get there. So say we look at the sine graph, right? So here's +1, here's -1. I start at 0, I go up, I come down, I come up again, and that is 2 pi. Okay, and we saw that when we looked at the unit circle. But what happens is it doesn't just stop at 0, and it just doesn't stop there at 2 pi. It keeps going. And the shape keeps repeating itself. Okay, that hump and then the valley, right? The sine function does that forever in both directions. Okay, the cosine does the same thing, it just has a different starting place. All right. This kind of pattern, it's called a phase shift. And actually, this is very closely tied in with things like music. Okay. I want to talk about that. We'll see if we have time. But we say sine and cosine are called periodic functions. A function. So we say a function is periodic if there exists a positive number c such that f of x plus c equals f of x. Right? So, well, I mean, the most basic example is 0 and 360 degrees, but we know okay, that the period of sine and cosine is 2 pi. So let's take a quick look. So if I did the sine of, I don't know, let's say pi over 3, okay, that gets us 0.866. And then if I take the sine of pi over 3 plus 2 pi, so I'm adding another 2 pi onto it, I get the same thing, right? And I can keep adding 2 pi. Every time I add 2 pi, I end up in the same position, right? And that's what we mean by periodic. Okay, so quickly, just because I reminded myself, for those of you who are music majors, whether instrumental or vocal, if you've ever listened to two people trying to tune, right? So, you know, the instrumental majors, you know, somebody plays a G, you know, so who usually it's like a flute or a clarinet that plays the G, and then the whole band tunes to them. If you listen closely, when you're out of tune, you'll hear this kind of like I don't know the lack. You'll hear a wave. Okay, so you play two notes that are close to each other, and you'll hear this like kind of bouncing, right? It won't sound solid, for lack of a better term. Well, that's because sound follows these waves. Okay, we can map sound into sine and cosine functions, and we'll talk about a little further when we're actually talking about the graphs. So when it doesn't line up like this, okay, it messes with our ears. Those sound waves are being picked up by our eardrums, right? And it's not hitting on them at the same time. As soon as you're in tune, okay, so, you know, say that's a trumpet playing, and then if a flute comes in and it's playing the same tune, right? The same pitch, the same note, those will overlap and they will sound like one thing. Okay, so trigonometry is immensely involved in sound. Okay, so I mean specifically, music and vocal, you're singing. So I just thought that was a neat little side thing. Okay. All right, so we'll continue. We'll wrap up this lesson tomorrow. We'll start going into trigonometry with triangles. Okay, so we'll take a brief look, and go back to some geometry topics.